Can you hear me? Com check, com check.
I can hear you.
Thank you. Okay, this material is going to come at you pretty quick, but it's pretty straightforward. However, I cannot recommend enough that you actually take the files that are given to you in the module and work with them and play with them, change them, try to write your own versions from scratch. That's really the best way to understand this material. We have two topics today. One is file I/O, one is exception handling. And in your projects, I have four main requirements, a GUI through JavaFX, a case of inheritance not related to the GUI somewhere in your software, file I/O, and exception handling. So this is two of the four main requirements. And they're both easily met because we're not asking you to do anything sophisticated here. Okay, so first of all, let's play around with writing to a file. And if you look at, let's see, here's where we are. Put that over there. And if you look, you'll see that we have some Java files and some class files. And by the time we're done running this piece of software, we're going to end up with a new file called scores.txt. Now, the files themselves, scores.txt, that's a physical file on the hard drive. That's the file itself. In order to interface with that, you need to treat it like an object. So the file, the Java language gives you the file object. And this thing serves as the interface between the Java virtual machine and the file itself. In this case, we're going to write to it. So we create something called a print writer. How do you know a print writer exists? Well, because of tutorials and because of lessons like this. Just learn by example. There are a couple different kinds of print writers, and again, you can find them in W3 Schools has good tutorials, and Tutorials Point has good tutorials for Java things. So here's what they do. They say, okay, we're going to have a new file and its name is going to be scores.txt. And then they take that file and they put it inside of a print writer. The print writer, think of it as the opposite of a scanner. What did a scanner do? A scanner was an object that was bringing data in. This is an object that is pushing data out. And all they do is they push out a couple lines of text. So everything is text when it gets pushed out. Print line John T. Smith 10, and then print Eric K. Jones, print line 57. This is just like what you have been seeing with console output, right? System.out.println prints a line and gives you a line feed at the end. System.out.print prints things out, but does not give you a line feed at the end. So whatever you print next is on the same line. And everything is treated as text. So John T. Smith 10, that's in double quotes, that's clearly a string. It's text. Eric K. Jones, clearly a string, that's text. 57 is an integer. However, it gets converted to text before it gets printed out. They name their file. That's fine if you only have one of them. If you have multiple files, you probably need to give them better names, input file, output file, something like that. They name their output, their print writer output. Again, that's fine if you only have one of these things. And then at the end, they do output.close. What's that? Well, when you open a file, that gives you access to the file. When you're done with it, you should close it. And this is good practice. It's good practice for a couple of reasons. One is it prevents conflicts. You can only have, generally speaking, you can only have a file opened by one entity at a time. You may have seen this if you go to Microsoft Word, you open up a file, it's up in Microsoft Word, then you try to open up that file again, you hopefully will get a message that says, this file is already open. Are you sure that you want to open it again? Because if you open it in 2 different locations, and you make changes in both, then whichever one you save last will have the changes that are saved and all the other changes get lost. And that's why they restrict, the systems generally restrict file access to one entity at a time. You open a file, it's generally locked for other users. They can't access it. And again, the reason is, what would happen if 2 different pieces of software open a file at the same time? They both make changes. Whose changes get saved? Well, whoever saved last. There's no mechanism to take everybody's changes and merge them into one place. If you're going to try to do that, you have to do more sophisticated things. Okay, so that's what closing does. It's also a resource issue. So if you open a file, generally there's some working memory dedicated to that file. When you close it, that working memory gets freed up. If you don't close it and you keep opening file after file after file, but even though you're not using them anymore, you're just taking up chunks of memory. You may have heard the term memory leak. Some software has a memory leak. The longer it runs, the more memory it takes up, until finally it takes over all your memory and the system crashes. Memory leaks are generally considered bad design. There's also a potential security issue. Files that are opened have buffers associated with them, and malicious actors can try to gain access to the file via the buffer. Buffer being temporary memory and active memory. So close the files. In theory, the only one who can open the file is some kind of an authorized user. And if you keep it open, if you're an authorized user and you keep it open, some malicious actor could potentially use that opening and get in, even though they're not an authorized user. You see that again on your let's say the shared machines inside of the labs at school. You log in with your username password, you only have access to certain files on that machine. You shouldn't have access to other people's files. But in theory, if they've opened up those files, then you could get access to them because it's already been opened by an authorized user. So that's the basics of what's happening here. It's really straightforward. We're doing simple file I/O. There is much more complicated I/O that can occur. We're doing text only, not binary. So you're not going to store images here. We're just doing text. But you create the file in a file object, put that file object in a print writer object, and then you can use it exactly like you're using system.out.println, system.out.print. When you're done, you close the file. So straightforward stuff. Let's see here. What's the name of this thing? Write data. If I do Java write data, nothing happens. But now if I look on my folder, scores.txt exists. That didn't exist a few minutes ago. I wonder if it'll let me do this. Yeah, no problem. You see the problem there? I've got it open and then I created a new version of it using the software. But if I edit this file and save it, those changes are lost. Okay. So that's all that's happening. We're writing out those things. And notice that Eric K. Jones 57 is on one line because we used the print, not the print ln for Eric K. Jones, and then 57 print ln. That's the that gives the new line. Pretty straightforward stuff. And printing out is really easy because everything is going to be a string. Now, technically, when you read things back, everything is a string too, unless you require otherwise, unless you specifically state otherwise. So we're going to read this data back using the read data file, and we're reading it back in the simplest but clumsiest way. So you can read your data back using this format. Your code and your project can look almost exactly like this. That's not a problem. Let's see here. So now when I read it back, all it does is echoes the file contents to the screen. How did that happen? Well, same trick. They create a file object for scores.txt. And then instead of, because they're doing input, not output, they build a scanner. Well, that's our old friend scanner, right? That's how you got input from the console. And remember, when you created a scanner, which is an input data stream, you had to tell the scanner where the input was coming from. So before you said system.in, which was the console. And now you say, oh, the data is coming from the file object. And then it just starts reading data. Now, we'll talk about the while loop in a minute, but string, first name, string, middle initial, string, last name, int score. So it's input.next. Everything is a string. So if you just say next, that's the default, right? Everything is a string. So you create a string, they create a string called first name, input.next. Input.next is just going to pull the next token. What's the next token? Well, the next token is anything that's separated by a white space. So John, and then it hits white space. So it says that's the next token. T, white space, that's the next token. Smith, white space, that's the next token. 10, white space, actually a line feed, that's the next token. You can create as many of these things as you want. I'm going to save that. And now when I write it again, it gets all of them. How does it do that? That's what this while loop is for. Input.hasNext. Has next means there's more data to come. There's more tokens. Every file at the end of it has something called an end of file marker. And those of you that came from the C class, I believe, had to actually worry about the end of file marker from time to time. If you took stuff out of a file, you had to move the end of file marker down. In MATLAB, you didn't have to worry about the end of file marker. MATLAB handles all of that for you. The good news, it makes the programming in MATLAB easier, and the bad news is you lose a little bit of control. End of file markers actually can be a security risk too. Because you can, if the end of file marker is actually like, here's all your usable data, and then here's some junk data, and then here's the end of file marker, you can insert malicious code into the junk data section, or you can insert hidden data into that extra section. Okay, so that's what input has next is. But pay attention to what's happening here in terms of data types. What this means is they expect, whoever wrote this expected that the file would be set up to be string, 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 int, string, 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 int, string, 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 int, right? That's the expectation. And if we break that expectation, we get an error. And we get an error right where you would expect. John T. Smith, 10. Oh, okay, string, 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 int. Eric K. Jones, 57, string, 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 int. And then we get an exception. And the exception actually came at the G. So it was Mary, yeah, that's a string. T, that's a string. Smith, that's a string. And then we try to get next int, and the system tries to convert a G to an int. And of course, that's not going to happen. So we get input mismatch exception. You told me you were going to give me an integer and you gave me the letter G. That's an input mismatch exception. So the lesson here is when you're doing your file IO for your own project, you're certainly welcome to use this very first, simplest, but clumsy technique. However, you have to plan ahead. You have to know what the format of your input file is going to look like. So when you're printing out, let's say these are, I don't know, high scores for a game. If you're printing out high scores for a game, think about how you're going to read them back in and make sure you print them out consistently with how they're reading back in. So they need to be printed out string, 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 int, string, 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 int. So you can read it back in as string, 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 int, right? You need to plan that ahead. Notice that theme keeps popping up. Just going to verify that I can fix it, right? Break things and then fix them. What if I do that? What do you think? Will that work or not work? Oops. I want me to hide it from you. What do you think? John T. Smith 10, will that work? No problem. Why did it work? John T. Smith, well, string, 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 int. John is a string, T is a string, Smith is a string, 10 is an int, no problem. But when we get down to that third line, 57 T. Smith 15, 57, is that a string? It must be. Everything is a string unless you claim it as otherwise. So that's not a problem at all. Well, it's a problem because there's a data error, but it won't cause failure. What about 15.0? 15.0, that's an integer, right? No, that's not an integer. That's a double, even though it's .0, .0. So I can show this to you, but again, this is why I'm saying you guys need to play with this stuff. This code is really critical that you run it and then manipulate it. Try to create something similar from scratch, which won't take that long. You can basically copy the model that you see here. Okay, questions so far? What if I put a bunch of spaces in there? Is that going to screw it up? Nope. Any white space counts. How about if I leave it out? Does that screw it up? It will. Let me run it once. Oh yeah, that's a problem. Why? Because it read Smith 15 as one string. See? Smith 15, that's one string. Questions about this?
Does that only read from like a .txt file, or can it work for other files too?
It doesn't matter the file extension as long as the data is actually this. So even though it's .txt, its format is text, but the .txt is not what makes it text. In fact, some of you guys are using comma-separated files, comma-separated value files, and those are generally .csv. They don't have to be, but they're generally .csv. So if we rename this .csv and change the code, it should work out. Some people put .dat for data. So if I need to change my, so if I go here to scores.text and change it to scores.dat. Oh yeah, I know. I'm showing them something. And I'll be very upset if this doesn't work. Cannot find. What can't it find? Scores.dat. Scores.text. Oh, I didn't recompile. That's what's wrong. There we go. There we go. So no, the extension is not the critical part. Okay, I better recompile and verify that it works, right? So, oh, see, I got a problem. Oh, I never saved it. There we go. There we go. Okay. That's why I say break it and fix it again. That's how you learn stuff. Any other questions? Okay. Now, what if I did, I'm going to do this replace text. Java, replace text. And I'm just going to do this. And it says, oh, usage. It should be Java replace text, source file, target file, old string, new string. That's what the, so it's giving me instructions on how to use the command. And we'll see that that's cooked right into the code here. So let's do this again. Oh gosh, I want to look at that file and see what's in there. Let's get rid of Smith and say, replace text. The source file is scores.text. Our target file will be new scores.text. The old string was Smith, and the new string is Smythe. How's that? And if we run this thing, I gotta get rid of that. If we run this thing and look at it, new scores.text, we've changed Smith to Smythe. So they're classier now, right? No offense to any Smiths in the class. All right, so how did that work? Well, it's pretty straightforward stuff. The first thing to notice, public static void main string args. We've never used that before. We're finally using it. Args, ARGS, is a variable. It's an input to the main method. What's its data type?
String array.
It's a string array, right? It says right there, string square brackets args. Therefore, it's an array of strings. And we've never used that array of strings before. That's what this is for, right? Here. And it's really intuitive when you're doing this on console. If you're in Eclipse, there are mechanisms by which you can put in your array of strings. And this is typically used with, particularly with command line code, where you have options that you can put into place. Again, if we just do Java with nothing else, it says, oh, look at all the stuff you can do. -ESA, -DSA, -agent lib, right? All these options that I can run with Java. Okay. So this is an array of strings. An array is an object. As you know, we can always find the length of an array, right? Array name dot length is an attribute associated with that object that tells us the length. So the first thing they do is they check, hey, they needed to give me 4 arguments. Did they? If not, tell them to give me 4 arguments. So that line that came out, let's see here. Usage, Java, replace text, source file, target file, old string, new string. Came right from there. The people who programmed this told me or gave me a clue as to how to use this class correctly. And that's always good advice. I mean, I'm sure you've had experienced a situation where you have an error and it says, you know, fatal error number 303. Now, that doesn't help anybody. I don't know what error 303 is. Whenever there's a possibility for error, it's helpful if you tell the user how to correct their error. And then they just quit, system exit. Oh, okay. So now what do? They check to see if the source file exists. Okay, if the source file does not exist, if you can't find that source file, then you print out this error message. By the way, where's the source file? It's the first position, the 0th position in the array. So it was replace text, source file, target file, old string, new string. Well, that source file is the 0th position in the array. Where's the new file? It's the first position in the array, the 1 index location. Oh, and if it already exists, they're not going to let you overwrite it. That's why I got that message, right? Target file already exists. So all they're doing here is just, you know, checking to see if the files exist. Now, normally you would put that in a try, throw, catch, and that's what I'm sure which we'll talk about in a little bit. And that's why I'm saying, you know, I don't want your exception handling to occur with file IO, because often files don't exist. So an alternate way of doing this is to do the exception handling techniques that we'll talk about in a little bit. In fact, they're actually trying it here. Then they do this. They create the scanner, right? Oh, you're getting input. So when you get input, you get a scanner. And the scanner, well, that comes from the source file. And then they create the print writer. Okay, when you're putting output to a file, you can use a print writer. There are other forms of file output, but a print writer is nice and basic and simple, and it works, and it meets your requirements for the course. And then that same trick, while input has next, while there's more stuff to process. And notice what they do here. They bring in an entire line at a time. This is one step up from the way we did it before. I told you before the way we read data previously in the previous example was the simplest, but also the clumsiest. And it was the simplest because it was reading one token at a time. String, 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 int, string, 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 int. Here they bring in the whole line, and they're bringing it in as a string. So that whole first, the whole first line, John T. Smith 10 comes in as a string. And then they just do a string, a pre-existing string method that comes with the string class. Replace all. args2 is the existing text, args3 is the new text. So what they're doing is using this replace all method. Replace all occurrences of args2 with args3. In our case, it was Smith and Smythe. So you can do some file manipulation pretty, you know, it's not a lot of code. Now, there are some drawbacks to all this. Every time we start to write to the file, we're overwriting the old file completely. So like if you had 100 lines of data in your file or 1,000 lines of data in your file and you wanted to add one more on the end and you use this technique, you would only get that one line because you're overwriting the old file. There are other ways to open files where you can append to the end, that kind of thing. But you can also do it this way. One way is if you have 1,000 lines in your file already, you open your file, you bring the entire file in to your program as a string array. You add that one line of text, and then you print the whole file back out. And now, even though it's it's overkill, it's wasteful, you've been able to save the entire file. There are advantages to doing things that way too, which is that you can manipulate the data in your code and then push it all back out to the file when you're done manipulating it. I like this little example. I think it's a good example for you guys to look at and play with and see what, see if you can change it and do stuff to it. How did you know that replace all was a string method that was available to you? That's what the Oracle help documents are for. That's what tutorials are for. It shouldn't shock you that since string is an object in Java, it has a whole lot of methods that are readily available. And they're, you should be able to do, string.length and things like that, just like with an array. So you can manipulate strings pretty easily because the object came with methods. How do you know what they are? Tutorials, Oracle help pages. Okay, so that's a quick rundown of what file I/O looks like. Again, we're doing simple file I/O. There are more complicated forms. There is, binary I/O. If you want to bring in images, you might bring them in bit by bit and play with them bit by bit. If you want to do, you can actually do save the state of entire classes. So in your program, you're at any point in time, your class has attribute values. Those attribute values have certain specific values associated with them. That's the state of that object. And you can actually save that whole thing. It's not saved this way. It's not saved with, not saved in string form. The advantage is when you bring it back in, the Java virtual machine knows the structure of that class and will automatically bring things in with the right attribute values in the right places. Just be aware that that's available to you. If you need it, then you go, then ask me for help. But in terms of what you need to do for your project requirements, this simple write to a string to a file, read a string from a file, that's all I'm asking you to do. Do we have, oh yeah, this one's not bad. It tells you all about the file. This is just giving you some examples of stuff you can do with the file class. Ask if the file exists, right? Can it be read? Can it be written? Okay, so you can get information about files. That's it. Just gives you an idea of there are things available to you. Again, the same as always. A student might ask, "Hey, can I do so and so to a file?" And my answer is going to be yes. And then they say, "How?" And I say, "I don't know." That's what you need to go look at the documentation for. That's why we have all the documentation. Okay. The next section to talk about today, and I know this is kind of coming at you quick, is the exception handling. And we start out with a good old quotient. Okay. And you guys know this, right? I'm going to take two integers, 5 and 2, and I get 2. Why? It's integers, so it's not 2.5. It gets truncated, and I can run it again, and I get 5 and 0. And sure enough, we get an arithmetic exception, division by 0. 0 and 5 works fine. Okay. So this arithmetic exception, division by zero, that's their basic example for developing exception handling. Now here's what you're going to see. Exception handling in Java and other programming languages have borrowed all of this terminology. And so it's very similar across different programming languages. You try something and you literally use the word try. And then if there's a problem while that code is executing, it throws an exception. That's the terminology, right? It literally throws out this exception. By exception, we mean error, right? An exception is something that will stop the process of the program. So you look here, oh, when I divided by zero, I got an arithmetic exception. If file is not found, I'll get a file not found exception. If the data types don't match, I expected an integer and you gave me a double, I'm going to get an input mismatch exception. So there's different kinds of exceptions. So you try something, the machine can throw an exception, and then you catch the exception. So you'll hear the term try, throw, catch quite often. Try it. If an exception is thrown, catch the exception. What happens when you catch the exception? You write software, you write your own code that performs an alternate action, right? If there was an exception, something must have gone wrong. So let's perform an alternate action and see if we can correct it. Maybe we ask the user to input the number again. Maybe, by the way, if you do, don't just say try again. Tell them what needs to be true, right? Tell them how to fix the problem. Maybe you use default values. Maybe for some reason, you ended up with a circle with a negative radius. That doesn't make any sense, so you just default it to 0, a radius of 0. You're allowed to have circles of 0 radius, right? That's a point. But you're generally not allowed to have circles of negative radius. Maybe you have, you can use these to protect your data. So if you know the good values are between 0 and 10,000, and someone throws 50,000 in there, you can correct that, right? You have a choice as to what you want to do with that. If it's supposed to be a numerical input and someone puts in a string input, you get an exception. You have a choice as to what to do with that exception. Maybe you, for some reason, null pointer exception. Maybe you tried to reference an object that you haven't created yet, or that hasn't been created by the software yet. If you get the null pointer exception, maybe your corrective action is to create the object and try again. Array out of bounds exception for arrays. If that happens, maybe your corrective action is to just ignore it. Somebody tried to do something to they're going down the array and they went off the end of the array. Maybe your action is to just ignore it because clearly there was just an error in the indexing. You have options as to what you do for corrective action. But the program doesn't terminate. That's the important part. Now, in these simple examples, because these are all straight line programs, the program terminates. Okay, so they're giving you this example of division by 0. How are we going to fix division by 0? Well, what's the next best way to fix division by 0? And you probably have been taught this. Put it in an if statement. Check to see if the denominator is divisible by 0. So now, if I run this, I can do my normal example, and I can do my 0 example, and I didn't get a failure because you checked, right? You checked for that with the if then else. This is not try, throw, catch. This is just what people are generally taught to do, right, for division. Hopefully you've been taught this and you follow this. But here's what the problem this doesn't fix. Oh, it wasn't even a number. I forget you're just checking by 0. You had to see if it was a number. So where is this program failing? Well, here we go. Number 1 is input next int. Okay, that's the 6. Number 2 is the input next int. Oh, that's the t. And so we actually threw an error there. So how are we going to fix this? The authors never fixed that specific problem. But what is an alternate way to fix these kinds of things? You put everything into this try, throw, catch. So here's what this quotient looks like with exception. And I'm going to focus on they write this little method here to do the division. They do this try and catch. Now, where's the throw? Oh, okay. You don't need to explicitly put throw in there because if you have a problem, the system, as you've seen, is happy to throw the error for you. In this example, they actually do explicitly put a throw in. It's try and catch. And what are you trying? Well, remember, one of the good things about Java, curly brackets always mean the same thing. Curly brackets mean sections of code. So try what? Try all the stuff between these two curly brackets. Oh, okay. What am I trying? I'm going to try to run this method. I might try to run that method. What if the method gives me a failure? Well, I'm going to catch it. You get to specify the kind of exception that you can handle. In this case, they specify arithmetic exception. So if someone tries to divide by 0, it's going to throw an error. It's an arithmetic exception, and I'm going to catch it. And then I can give some corrective action. The corrective action here is pretty bland because they just tell you, hey, you messed up, and then they still quit the program anyway. But as they point out, if this was a real program, then the program didn't crash because of the arithmetic exception. You can still keep doing things. All right, so what happens with this quotient method? By the way, they make it static. Bad programmers. You take in two numbers, and then if number 2 is equal to 0, they're still checking for it. Right? Then they throw a new arithmetic exception, and here's the text message that comes out: divisor cannot be 0. So if I try this thing, quotient with exception, and I try to divide by 0, exception, an integer cannot be divided by 0. Where's my, no, they printed that out right there. They should have just printed out the exception. Okay, all right. But notice what they did. You can actually choose to throw an exception. So in other words, if you had something that was not technically going to crash the program, but you didn't like it, you can still flag it. I'm only allowed to have aircraft altitudes between 0 and 60,000 feet, and someone put in negative 15,000. Well, that's a problem. Even though negative 15,000 is still a number, it's illegal, right? It's a legal data type. I can still choose to throw the exception to flag that something went wrong. Somehow my program calculated airplanes underground. I should probably look at that. I should have a warning that my data is not good. So try, throw, catch. Generally these things don't are not explicit. Generally, you anticipate what kind of exceptions you might get, and then you catch them. Now, notice what was not caught. Input mismatch was not caught. Quotient with exception. 6. Oh, input mismatch exception. So what could we have done here? We could have added to the catch. You're allowed to say, I'm going to catch with arithmetic exceptions. You can have another catch for input mismatch. You can have another catch for array out of bounds. You can have as many catches as you want, and then you might have to take different corrective action depending on what the kind of error that you received. So try, throw, catch. It's a fairly simple technique, but I would, again, recommend that you play with these files and try to build your own from scratch. Build a simple try, throw, catch structure from scratch. Don't try to do it the first time in your code. Right? You've got too much code to play with there. And if you do something where you're just doing something this simple, then you can focus on try, throw, catch. Same with the file IO. Just try to build a file writer from scratch, a file reader from scratch. That's not an exact duplicate of the examples here. And then the last demo, this is again, they're all silly examples, right? This one has main, and then it has method 1, and then it has method 2. And they made everything static, which makes my skin crawl. But notice what they say. Method 1 throws exceptions. So if you have a method that may throw an exception, generally you have to put that in the signature. And all they're going to do here, it's ridiculously simple code, right? They're going to all main does is it calls method 1. All method 1 does is it calls method 2. All method 2 does, literally all it does is throws an exception. And it's a generic exception, right? It just says exception. It's not a specific arithmetic exception or null pointer exception. It's a generic exception. You are allowed to catch generic exceptions. And all it does is it throws it. Well, where does it throw it to? Well, who called method 2? Method 1 called method 2. So there's the try block, and it's going to catch the exception. And weirdly enough, if method 1 catches an exception, it throws a brand new one. And it passes that information back up to main. And then all main does is it prints out the stack trace. You've seen the stack trace before. You see it here. So if we run this thing, and again, it's giving you all the information of where this stuff came from. If you are not reading these error messages that you get when your programs don't work, please start reading them. They have really good information in them. I mean, look at what's happening here. It's telling you it's info from method 1, and it says chained exception demo method 1. Why? From method 2, okay. It's telling you the path that your program was taking to get to the failure point. The first line is always telling you what the exception type was. And generally, they're going to tell you the at util scanner next int. And if we keep going, then, oh, okay, so I need to, something went wrong with the next int method. Well, where's my next int method? I can look at my code and find it. Usually they tell you the line of code, and usually pretty good at it. So please read those things. All right, so this chained exception demo, why would you do that? What's the reason for that? Remember how you're supposed to build object-oriented code. I keep telling you, don't make these great big methods that do a lot of work. Make little tiny methods that do very small specific jobs. And then how do you make a big method? Well, the big method calls this method, right? And then it calls another one, and then it calls another one. Well, you may have a method that calls a method. That method calls a method. That method calls a method. Now you get an exception. Because that method is doing a little tiny job, it doesn't have much information. So it may not be able to perform the corrective action that you need performed. Maybe the method way up here is the only one that has enough of the control and information, access to resources to perform the corrective action. So that little tiny method doesn't even try. It just, you throw it back up to the higher level method. You throw it back up until finally you get to a point where you want to actually deal with the exception. That's the reason that you use the chained exceptions. I do not think that, I don't think anybody in this class will need to do that for your project. You can stay with the simple ones. To meet your project goals, it's really simple. You ever go through an array You know, in a for loop, you're going through an array. Even though you should theoretically never go out of bounds, throw it in a try, throw, catch block and catch array out of bounds exceptions. Even if it's not used, it's good defensive programming, number one. And number two, you're showing me in your code that you did a try, throw, catch block. You have input from the user where they're supposed to put a number in a text field. Do a try, throw, catch and check for the input mismatch error. If they try to put a letter in there instead of a number, then you can catch it and you know, correct them. Let them try again. So in terms of your project, both the file IO and the exception handling can be pretty simple stuff. I'm asking you to do pretty simple stuff, but you're not going to be able to do it, and I don't think, unless you take these examples and read in the textbook and take examples that are online and learn from those and physically make your own files. Forget your project. Physically make your own files, try to run them, see if you can make them work. You also have labs on these things too. Okay, we're over time. Are there questions before we go?
Was that a generic exception when you're trying to catch that? Does that catch any kind of exception, no matter the type?
Yeah, and I'm not a fan only because I'm a fan because it catches everything. I'm not a fan because it's harder to figure out what you caught. Right. Usually you want to know the kind of exceptions so that you can define the appropriate corrective action. Now, having said that, if you catch a generic one, I'm sure you can query it as to its type, but how annoying. Other questions? Okay. All right, guys. See you on Friday.